Hi there, Taylor here to talk to you about the Ethereum Easy library. This library makes operating on the Ethereum blockchain easier by abstracting away the challenges of using the Web3 library into 5 simple function calls. Specifically, we're going to be looking at the deploy contract, contract call, contract send, and listen methods within the library. These methods are specifically related to dealing with smart contracts in a live Ethereum environment, and they will be what we are using to demonstrate this library for this example. For this demonstration, we have implemented a game of rock, paper, scissors over the Ethereum blockchain. As a review, in rock, paper, scissors, each user selects a hand signal to represent rock, paper, or scissors. When the game is decided, any player who has selected paper is going to beat any player who has selected rock. Rock beats scissors, and scissors beats paper. So in this logic, we can understand who wins the game from their initial decision. In our version of this rock, paper, scissors game, each node will initially make a selection of rock, paper, or scissors and begin to implement or record this information onto the Ethereum blockchain. I will take you step by step through our process for recording and looking at this information on the blockchain and give you detailed descriptions on how we use our library to make this possible. To facilitate this rock, paper, scissors game, we have 2 smart contracts. The first is the game contract, which contains information about each player's throw that they decide at the beginning of the game. P1 throw is the throw that the first player, player 1, will be recording onto the blockchain, and player P2 throw is likewise the throw that player 2 will record onto the blockchain. The game contract smart contract is deployed in-game to demonstrate our deploy contract function. Finally, the rock, paper, scissors game does follow a commitment scheme so that each player only records an encoded version of their throw to the game contract when they initially record their answer on this contract. This allows each player to reveal their answer once they know their opponent has correctly responded to the game contract. More information on the commitment scheme can be found in my commitment scheme addendum video for this demonstration. The state contract is the second smart contract that we will be using for this rock, paper, scissors game. It is used to communicate the state of each player to its opponent. It is also used to communicate the address of the game smart contract once it is deployed by player 1. And finally, it is used to communicate the reveal keys, or the keys to decode the deployed throws of each player on the game contract. Finally, the game moves through a series of states that help each node determine what processes in the game it should be invoking. We can see the list of states here: init, ready, deploying, submitting answer, submitted, committed, and reveal. We will go through each of these states for each of the 2 nodes in our game in the following portion of the demonstration. We are going to begin our game by opening 2 terminal windows and navigating to the RPS directory. Within this directory, we are going to run the app.js module to get the game started. We're also going to provide 2 different arguments for each terminal. The first argument is the player that node or that terminal window will represent, and the second argument is the throw that player is choosing for the game of rock, paper, scissors. As you can see here, we have player 1 as rock and player 2 as paper. When app.js is run for each of the nodes, they will initialize into an init state, and this is to indicate the very beginning of the game. We can see this diagram here showing the init state for each player and the 2 smart contracts that we will be working with across the game. While in the init state, both players will use the listen function of the Valve library to start monitoring the state contract in our pair of smart contracts. Monitoring the smart contracts with the listen function will allow each node to be notified when there's an update to any of the variables in the state contract. When a node receives a notification of an update to the state contract, this will trigger further game logic to move the current node into a new state or recognize that there is new information on the state contract that is valuable to that node. After 3 seconds, player 1 will enter a ready state. This state is communicated to player 2 by using the contract send function in the Valve library to add the ready state for player 1 onto the state contract. Because player 2 is notified through the listen function that there's an update to the state contract, it then can update its state to ready on the state contract as well. Now both players have confirmed that they're online and ready to begin the game. Once player 2 updates their state to ready, this will trigger player 1 to move on to its next state, deploying. When player 1 is in the deploying state, it will deploy the game contract to the Ethereum blockchain so that the communication of the throws of each player can begin. When player 1 has confirmation that the game contract has been successfully deployed in the blockchain, it is going to update the state contract to submitting answer. In the submitting answer phase, player 1 is going to submit their throw encoded in a Caesar cipher to the game contract. When player 1 has confirmation from the blockchain that their game contract submission has been recorded, they will update their state to submitted. When player 2 has confirmation of player 1 being in the submitted state, it will move into the submitting answer phase. Just like player 1 in player 2's submitting answer phase, it will write its throw encoded in a Caesar cipher onto the game contract smart contract using the contract send function. When player 2 gets confirmation that their throw has been added to the game contract, they will update their state on the state contract to submitted. This will trigger player 1 to move from their current state to the committed state. In the committed state, player 1 is going to check to make sure that there is an encoded solution or an encoded throw for player 2 in the game contract. When player 1 has confirmation that player 2 has submitted an answer to the game contract, it will update its state to committed on the state contract smart contract. Likewise, when player 2 has confirmation that player 1 is in the committed state, player 2 will also check to make sure that there is an answer for player 1 on the game contract. Now both players are confident that each opponent has submitted an answer to the game contract, meaning that they can finish the game. In order to do this, they will post their reveal keys to the state contract for the other one to read. When each player has the reveal key of their opponent, they can decode the message that is posted to the game contract and see who is the winner. To review, we have covered most of the functions available in the Ethereum Easy node library. Deploy contract is used when we deploy the game contract up to the Ethereum blockchain. Contract call is used whenever we want to call static information off of the smart contracts that we have deployed. Contract send is invoked whenever we need to update stateful information on the smart contracts we have deployed, and the listen function is used to indicate to our nodes when there has been a change made to one of the smart contracts that is in use.